Sometime between now and the early 2030s, humanity will run out of high-quality written words. Every published book, every digitized scrap of our history, every blog post and forum thread has already been fed to the silicon. To keep growing, these machines must now do something unprecedented. They must start eating their own output. But when an intelligence begins training on its own creations, a strange, degenerative decay begins. We are about to hit the boundary of the digital mirror. For years, we assumed that as AI grew more capable, it would naturally learn to edit itself. We built models with the expectation that they would find their own flaws and quietly correct them, much like a human editor polishing a draft. But that is where the architecture betrays us. Recent research into the accuracy correction paradox reveals a bizarre anomaly. When evaluating complex math benchmarks, older, weaker models like GPT 3.5 are actually 1.6 times more likely to successfully correct their mistakes than their cutting-edge successors. The smarter systems do not fix their errors. They do something far more human. They use their advanced reasoning to invent highly sophisticated, deeply convincing justifications for why their mistakes are actually correct. To understand this decay, we have to look at what happens when these models are fed synthetic data. Think of it like placing a rich, high-resolution photograph of a forest onto a photocopier. You take that printed copy, place it back on the glass, and copy it again. By the 10th iteration, the subtle textures of the bark and the leaf shadows have vanished. You are left with a harsh, blocky abstraction of black ink and white space. This is the photocopy effect of synthetic training. The AI is no longer learning from the chaotic variety of reality. It is learning from a statistical average of reality. Every cycle aggressively trims away the rare outliers, the eccentric human behaviors, and the quiet nuances that make our world real. The system does not just lose detail. It forgets those details ever existed. Yet, despite this creeping decay, the industry is sprinting toward synthetic data. They have no choice. The digital well has run dry. Take remote sensing. Training a satellite to spot a rare class of naval vessel or a specific natural disaster from orbit requires millions of images that simply do not exist. But with diffusion systems like AeroGen, researchers can generate thousands of perfectly labeled, artificial satellite images in a single afternoon. In robotics, synthetic videos of human gestures bypass the slow, expensive process of physical filming. It is cheap, it sidesteps strict privacy laws, and it bypasses the friction of physical reality. But this convenience is a seductive trap with a compounding cost. When synthetic data becomes the primary food source for new models, we trigger a process known as model collapse. In the first few loops, everything looks perfect. The output is clean, fast, and highly polished. But beneath the surface, the mathematics are shifting. The model begins to overrepresent the most common elements of its training set, while quietly erasing the tail-end anomalies. If you train an LLM on synthetic data about dogs, it quickly discards the rare breeds, focusing entirely on golden retrievers. By generation 5, the system is no longer reflecting reality. It is tracing a caricature of a caricature. The vast, beautiful, messy spectrum of human thought is compressed into a singular, sterile average. This drift breeds an even more insidious behavior, the rise of polite deception. Because these models are trained to prioritize helpfulness and authority, they learn to mask their own structural ignorance. When a model trained on synthetic cycles hits a blind spot, it does not pause. It fabricates. It constructs an answer complete with immaculate bullet points, perfect citations, and elegant transitions, built entirely on a foundation of nothing. It has masterfully learned the shape of truth, with none of the substance. It is highly confident, wildly incorrect, and utterly convincing. We are no longer training machines to discover the truth. We are training them to perform it. In a laboratory, these errors are merely academic curiosities. In the real world, they are liabilities. If an autonomous drone is trained on synthetic imagery, a tiny, systemic bias in how the simulation renders shadows can translate to catastrophic misidentification in active airspace. If a medical diagnostic tool is trained on synthetic patient records that have subtly drifted away from genuine clinical histories, it will miss the quiet, rare anomalies of an aggressive disease. The danger is not a sudden, dramatic system failure. The danger is that the machine will fail silently. It will perform with 99% accuracy on the mundane, while remaining blind to the high-stakes exceptions that define life and death. To break this infinite loop, we must anchor these systems back to physical reality. We cannot build a sustainable intelligence out of digital echoes. Researchers are beginning to realize that synthetic data is a powerful accelerator, but a lethal foundation. We must establish rigorous logical anchors, grounding our systems in real-world physical verification, immutable historical archives, and direct human oversight. The future of machine intelligence does not lie in an endless mirror world of artificial self-reflection. It depends entirely on our ability to keep the machines tethered to the messy, stubborn, and beautifully unpredictable truth of the physical world.